Hello and welcome to ZEBx's October webinar, co-hosted with our fellow ZEBx program area, Carbon Leadership Forum BC. If I haven't already had the pleasure of meeting you, my name is Natalie Douglas and I'm the ZEBx program manager. Today we'll be hearing from two of the practitioners involved in the Marpole Community Centre project. This passive house building also served as a pilot project to test the City of Vancouver's embodied carbon guidelines, offering itself as a fascinating case study for reducing both embodied and operational emissions while keeping a series of other guiding principles top of mind. To kick things off in a good way, I'd first like to share my gratitude to be able to join you today from the unceded traditional territories of the Musqueam, Squamish, and Tsleil-Waututh Nations, and to give thanks to the City of Vancouver, North Family Foundation, and BC Hydro for their financial support to make these free educational webinar series a reality. If you're interested in getting continuing education credits for attending today, please see the information that Kim, my colleague, is going to drop into the chat. Please also use the chat to comment and ask questions for the presenters and the rest of the audience. We'll use those questions to help guide discussion near the end of the hour. Just a reminder that ZEBx is part of a family of program areas nested within the federally endowed Zero Emissions Innovation Centre, otherwise known as ZEEC, the BC contingent of the Low Carbon Cities Network. ZEBx is part of the Building Decarbonization team and can be understood as the main convener and amplifier of content developed by this team. We're the first point of contact for those who are either unsure of how to approach the world of building decarbonization or just want to be updated about it all. No shame in that. If you want to learn more about electrification, check out V2.0, BC Retrofit Accelerator for retrofits, Near Zero for research and incentives, Carbon Leadership Forum BC for all things embodied carbon. ZEBx compiles and synthesizes content from all the specialist program areas to promote cross-program interdisciplinary work. Now, ZEEC is more than just the building decarb team. I have colleagues who specialize in communications, economic transformation, and granting, but all really working towards accelerating decarbonization. Now, as I introduce my co-host, my colleague Kim is going to launch the first poll to help us get a sense of who is in the room today. I'm thrilled to be co-hosting today's webinar, not only with my colleague Stephanie Dallow, Program Manager of Carbon Leadership Forum, who's going to be active in the chat and help close things out at the end of the webinar, but also with Susan McDougall, Principal at Focal Engineering. Susan will kick things off today by introducing herself and affiliated organizations, contextualize the importance of today's topic, and introduce our wonderful speakers from Diamond Schmitt and Reload Sustainability. Over to you, Susan.
So as Natalie mentioned, I was invited in part due to my role as CEO of Focal Engineering, because we too spend all day, every day, reducing carbon on new and existing buildings. And we've also worked with both companies presenting today. We have really high respect for them, and I'm excited to hear talk. However, I'm also here in my capacity as board member at Passive House Canada. As many of you likely know, last June we had our conference in two passive house buildings at the University of Victoria. And before the conference, the board and the staff met for quite a while to discuss a new strategic plan for Passive House Canada moving 2025 onwards. It's still in progress. Strategic plans take a while. And so we don't have all the deals formalized, but I can definitely share that one of the recurring themes was how many passive house owners are really keenly interested in not just operational, but embodied carbon. And so we're looking at, how can Passive House Canada adapt to really reflect this? So yeah, I'm very excited to see this presentation today and hear how these goals have materialized into a real project. So without further ado, I'll hand that over to Carolyn.
Thank you. And Forrest, if you could start sharing your slides, please. Thank you. So again, my name is Carolyn. I'm an architect with Diamond Schmitt. I'm one of the architects on the Marpole Community Centre, and I'm just really excited to be able to share this project with you. I'm also here with Forrest from Reload to help me get into some of the weeds for you. So next slide, please. Our agenda for today, I'm going to give you a brief project introduction. As part of that, I want to go over our values, vision, principles, and goals for the project. I want to focus on two goals, and that will be balancing the operational and embodied carbon for the project. And then I'm going to hand it over to Forrest, who's going to go into more detail about how we achieved our embodied carbon reductions. And then we're going to come back together at the end for a Q&A. So next slide. Next again for the project stats. So The Marpole Community Centre is a community center and childcare facility located in the Marpole community in South Vancouver. Our client is the City of Vancouver as well as the Vancouver Parks Board. The project is currently under construction and is phase 1 is scheduled for completion in 2026. The approximate size is about 6,000 square meters, plus an underground parkade. A lot of ambitious targets for this project. Passive House certification, LEED Gold certification, a 40% embodied carbon reduction, as well as the Rick Hansen Foundation's accessibility certification goal. So in order to bring all of these targets together, we came up with a project vision. Go to the next slide. So our vision for this project is to make the Marpole Community Centre the most inclusive, forward-thinking, and high-performing facility the City of Vancouver has ever had. This is the first community center for the City of Vancouver since the Trout Lake Community Center in 2012. There are a lot of eyes on this project. A lot of departments were involved, a lot of ambitions to really cement the City of Vancouver as a leader in this space. Next slide. So working back from that vision, I'm just going to break it down into our values and principles and goals that all feed into that vision. So next slide. So we have our vision in the center, and that is fed by our values, which are universal, as well as our principles and goals, which are project specific. So starting from that vision, so we go to the next slide. Again, that very, very ambitious vision. We then break it down into our values. So next slide. So in order to do that, we had a series of workshops with representatives from the City of Vancouver, from our consultant group, from the Vancouver Parks Board, across all sorts of departments to understand what was important to everyone involved in the project so that we could embed that into the project charter. So if you go to the next slide, together we came up with 13 values for this project, loosely organized in 3 themes. So you'll also notice that some of these themes, some of these values work with more than one theme. So as an example, we've got reconciliation, which is associated with the humanism theme, but there are implications there for our other themes for society and environment. Similarly, health and wellness, we've grouped under humanism, but there's knock-on implications to environment. If we are supporting health and wellness of the community by supporting active transportation, that is also supporting our environmental goals. So from these 13 values, I want to speak to you specifically about one, next slide, and that is energy and carbon. So next slide. Our principle for this value is to aggressively minimize greenhouse gas emissions associated with the operation and construction of the facility. So now that we know what we want to do, we have to break it down into goals to figure out how to get there. Go to the next slide. These are our 4 goals associated with this value. So number 1 is to eliminate the use of fossil fuels. We did this by designing an all-electric building, so there is no natural gas connection to this community center. That includes the pool as well, and even the backup power supply. So number 2 is to generate renewable energy on site. There are photovoltaics on the roof of the building, which feed into a backup battery, which provides our emergency power supply. So there's no diesel, there's no fossil fuels on this building so that we can help meet our operational carbon goals. The third target is the passive house target. So achieving a TEDI of less than 15 kilowatt hours per square meter per pole, and this is addressing operational carbon. And number 4 is to reduce the embodied carbon intensity of the building by 40%, which is something that Borch is going to go into more details on. Next slide. I wanted to talk to you about all of our goals because it was important for me to explain that this target of a 40% embodied carbon reduction exists in an ecosystem of many, many goals and many targets. So if you click next, you'll see it circled in black. And the importance of that is when we're making decisions on embodied carbon, we have to make sure we're not undermining the rest of our goals and the rest of our targets in this project. So if you go to the next slide, again, just a continuation of all of the values and principles and goals for this project. So next slide. Sometimes all of these goals work together, and that's great. That's ideal. An example would be our parking reductions. So we explored parking reductions on this project because of our responsibility value. So one of the goals is to respect the project budget and schedule. We were given the mandate that no park space should be given over to surface parking on this project. That meant that all parking had to be provided in an underground parkade. The bylaw requirements for parking for a building of this size would have amounted to about 250 parking stalls, which when all laid out was about 7,000 square meters of parking, which is more area for parking than for community programming. And because it's underground parkade, it's very cost prohibitive. And so in order to meet that goal of respecting the project budget and schedule, we looked to aggressively reducing our parking counts. We did this by working with a transportation consultant to help us implement transportation demand measures to reduce the parking count. And those TDM strategies also worked or had overlap with our other goals. So the goals under mobility, or the targets under mobility, were to provide safe, secure, convenient bicycle storage or bicycle parking, and to support electrical charging for those who need it. So by implementing those goals, we were able to reduce our parking count and therefore reduce the embodied carbon in the building, as well as meet another goal under waste reduction, which was to minimize the use of materials. Next slide. Another example of these goals working together is the decision to use a mass timber construction for the structural system. So this met our goal under biophilia to prioritize the use of natural materials, as well as reducing the embodied carbon in the building by using timber instead of concrete and steel. However, sometimes there is some contradiction in the goals. So if you click next, there is a premium for mass timber construction, and because of supply-drain pressures in our industry right now, there are potential impacts to schedule. So we needed to find ways to use a mass timber system while still respecting the project budget and schedule. And how we did this is to work with a construction manager who allowed us to tender the structural system early so that we could work with a mass timber supplier in BC, and when we needed to revise our design so that it could meet the project budget and schedule. Slide. So continuing with that theme of goals that are seemingly at odds is the discussion between balancing operational and embodied carbon goals. Next slide. So, and this is the discussion between passive house and embodied carbon. So one of our goals, or one of our targets, is to achieve passive house certification. So that TEDI of less than 15 kilowatt hours per square meter per year. And in order to reduce operational carbon, one of the best ways to do that is to improve your building envelope so that less energy is needed to heat and cool the space. But the trade-off on that is that by increasing your building envelope, you're increasing the amount of materials needed for the building and therefore increasing your embodied carbon. So next slide. Before I go too far, I just wanted to give a little passive house primer in terms of the actual targets for passive house. So I guess passive house basics is that a passive house building has to meet two targets: a TEDI of less than 15 kilowatt hours per square meter per year, and an airtightness testing of 0.6 air changes per hour. So it's a low energy building that's very airtight. And if you go to the next slide, Passive House Institute has released Passive House principles that will help you or help designers achieve that. And for some of these, there are carbon implications, including thermal insulation. So the wall assembly of the Marpole Community Centre is about 8 inches of insulation. So that's a lot of material and a lot of embodied carbon. Another one is passive house windows. So we have triple glazed windows. So again, a lot of material, a lot more embodied carbon, also air tightness. So different membranes and thermal bridge reduced design. So specialized components to create thermal breaks. So all of these impact your embodied carbon in the building. So and need to be taken into consideration so that you're not prioritizing operational over embodied carbon reductions. But another way to improve your passive house modeling, and probably the #1 piece of advice the passive house designer or consultant will give you, is to improve your form factor. And what that means is to reduce the amount of building enclosure needed to enclose the building or the volume. And how that helps you from a passive house perspective is there's less surface area for thermal heat gains and losses. And how that helps you from an embodied carbon perspective is that if there's less area of building enclosure, there's less embodied carbon. So knowing that, we use that strategy to influence our building planning. The next slide. Going to walk you through the building planning, just to illustrate this. So the first thing we did was to decouple the pool function from the community center. Because the community center is the passive house building, and the pool function, the pool is a seasonal program, and the spaces associated with the pool are indoor-outdoor spaces. And that's not great for passive house and for air tightness. So if we just remove it from the passive house enclosure, we're improving our passive modeling. Next. So then we can focus on the community center itself. And the first thing we did here was to, so when we're looking at organizing the spaces, we're breaking it up into the different components and what they need in terms of heating and cooling. So we start with the gymnasium. It's a large volume we're just putting it tight against Oak Street to help buffer the rest of the building and the building programs from that loud arterial road. Next slide. Next, we locate the fitness and recreation programs, which are programs where people are generating a lot of heat. They're working out, they're doing cardio, it's getting hot and sweaty in there. And so by locating them on the north aspect of the building, we can benefit from passive cooling. The multipurpose rooms are located along the south bar because these are more passive areas. People are attending lectures, going to luncheons, or it's after school care. So these are spaces that really benefit from those solar heat gains and that southern exposure. Next slide. Next, we introduced a circulation spine, which we've called the main hall. So it's an east-west axis that connects views to the park on either side. And the other move that we did here is we've removed the vertical circulation from the passive house enclosure. That's that yellow tower in the bottom right-hand corner of the building. And we did that to reduce thermal bridging. So elevators are not airtight, and the elevator is connected to the parkade. So if we can reduce the amount of unconditioned parkade air just opening right into the building, we can improve the passive house modeling as well. So next slide. And the final program component is the childcare, which is located on level 2. Again, nestled behind the gymnasium so that it's protected from Oak Street. And opening up that play space on the south side of the building so that it's benefiting from that southern exposure. It's also protected by the solar panels. So where it says buffer, that's where our solar panel array is. And again, it's just to protect those child spaces from Oak Street and those busier areas. Next slide. So this is a red line diagram. It's a tool used in Passive House to define the Passive House enclosure. So you can see that the building is relatively simple in terms of its mapping, and it's very intentionally done so that we are reducing the amount of building envelope and therefore reducing the thermal heat gains and losses, as well as reducing the amount of material needed to enclose the building. So this is level 1. And just you can see in the bottom right-hand corner, that vertical circulation just carved right out of the building to improve our Passive House modeling. And then on level 2, next slide, is the childcare. And again, you can see very simple massing, reducing the articulation as much as possible to create a very effective form factor. Next slide. And just to end on a pretty picture so that you could see how it all comes together. So by incorporating these Passive House principles and this logic in terms of form factor into the planning of the building, we can meet our sustainability goals when it comes to embodied carbon as well as operational carbon. So it's not a trade-off. And I will pass it over to Forrest now.
Thanks, Carolyn. And thank you everyone for joining today. I'm really excited to share the results and how we got there for achieving the embodied carbon reductions for this project. My name is Forrest, and I am the embodied carbon lead at Reload Sustainable Design, where, we specialize in building design advisory, performance analysis. We manage the performance of buildings under these certifications and incentive studies, as well as working on climate adaptation and resilience. Work on a number of different project types, including healthcare, institutional, MURBs, and community centers like we're talking about today. To dig into the outline that I'll be sharing with you, we have the project context and goal overview, then the baseline for this project and how it evolved in relationship to the City of Vancouver Embodied Carbon Guidelines. And then I'll talk about the low carbon design strategies. I'll mention that these strategies are also featured on the CLFBC website, so you can take a look there, and I'll try to share some details that are additive to that conversation as well. But to talk about where this 40% reduction target came from, we have to look at the City of Vancouver Climate Action Plan. So here you can see that they're targeting a 40% reduction compared to 2018. So that's where this project target came from. And that's because we are in a climate crisis right now where we're seeing flooding, increased wildfires, and heat domes with an ever-increasing average temperature in Vancouver. So the cities recognized that and identified embodied carbon emissions reductions as one of the key strategies to address this crisis. This project took that 40% reduction goal, and at the very beginning, we set some performance-based targets. So we understand that we have to be 40% less, but 40% below what? And what is that baseline? So we looked at benchmarking first, and we know that there is available benchmarking information for MURBs, but not that many databases that have community centers out there. So we started with this 250. Let's see if we can hit that in the preliminary design stage. Remember that number, I'll come back to that later on. We also had this GHGI goal of 1.1 kilogram CO2 per square meter. That relates to the Passive House project as well. So talking about the baseline embodied carbon for this project, we had this OPR 40% reduction based on a 2018 baseline. So what is that baseline? We had to have a lot of conversations with the City of Vancouver and Diamond Schmitt to establish a building that would have been constructed in 2018 to generate an additional baseline. And at that time, there was little guidance out there for how to approach this problem. In 2021, the first draft of the then called LCA modeling guidelines was released. And we used that draft in our first whole building LCA to provide feedback to the City of Vancouver on implementation, whether it was forming a good baseline, whether we could game it. We tried to break it and gave feedback on how it could be fixed. And then the baseline changed again when the Concrete BC released their member-wide EPD that focused on British Columbia concrete versus Canadian industry-wide. So our baseline changed there because we know that Concrete BC is relatively lower embodied carbon than Canadian concrete. And then for our building permit, this is where a key milestone for achieving this 40% target, where we used the embodied carbon guidelines version 0.3, which are much improved from the LCA modeling guidelines initially, including the name. And we now have version 1 that had been released a little bit later. So we checked the BP whole building LCA against what we had done previously, and that's the results that we're seeing on screen today. When we were developing this baseline, we had these questions like, how much parking does the baseline have? Or should the baseline insulation be VBBL or passive house? Are we penalizing our project for having additional insulation? And as well, is wood carbon negative? Are we counting the biogenic carbon for this project? So the COV embodied carbon guidelines answer each of these questions now. So they state that we must, the baseline can have the minimum parking in the City of Vancouver parking bylaws, or what used to be in those minimum parking requirements. That the thermal equivalence should be maintained. So there should be the same number of panes of glass, the same thermal equivalence for the envelope, and that's referencing the Clearfield values for the energy modeling folk up there. And as well that biogenic carbon is counted separately. So the baseline that we developed was a steel superstructure and a concrete substructure for this project. I'll now talk about the design. And for this project, we not only had time, cost, and quality, we were also constrained by carbon. And so Diamond Schmitt was really involved in, or really great at involving us in the design where it mattered and providing a carbon context to each major decision that was made. Here's a quick figure on how embodied carbon can integrate into the design process. And this two key points that I want to focus on in this presentation are in the pre-design and in the pre-construction phases. So we'll get into that a little bit more, but these are kind of the main players that we'd like to see in this process. In this pre-design stage, as Carolyn mentioned, we have massing analysis. So we assigned carbon intensities to the different building elements and looked at their relative embodied carbon. And what we found from that is staying away from Scheme B was a good idea. I'll mention that the baseline for Scheme B was never developed, that the baseline for Scheme A was gone with. So from that perspective, this project is achieving more embodied carbon reduction than we would have had we gone with a different building structure. A key way that we interrogated the design and used the analysis to inform the design was through contribution analyses. So I'll show two different ways that we look at this. One is by material type. You can see that the baseline had significant amount of concrete and metal, as well as thermal and moisture protection. And the proposed was mainly concrete, metals, much more wood because we have a mass timber structure, and slightly less thermal embodied carbon emissions from those materials. And I'll dig into why those emissions came like that in the following slides as well. Here's another way that we look at contribution analysis. And something I'd like to point out here is that you'll see steel beams across childcare and in the gymnasium. Those long spans is something we did analyze for mass timber versus steel. And it was very close from an embodied carbon perspective, but those other goals that Carolyn mentioned were a big factor in choosing that. And a big part of that is because we had to double up the mass timber beams just with the way they're fabricated to meet the structural load. which added a lot of volume to the mass timber. So from that perspective, we're using the materials that are suited to the specific area and not just choosing a material because it's inherently deemed to be better. Getting into the later stage of the analysis and the project that I was talking about with these submittals, I'm going to go through this in a little detail because I think this is one of the key pieces for this project, is that for each key contributing material that we identified, we're asking for a base bid, which is a business as usual, and also a lower carbon bid. So 2 bids, we want to see the price for those 2, and then the team can choose between that. We also want to see a completed embodied carbon tracking form with these different bids, and I'll show that on the next slide. These have to be backed up by EPDs. If you don't have an EPD, then we'll use an industry average and ask you to answer these questions, which nobody did. So next time we're not going to include these questions because that was too much to ask. Here's an example of the embodied carbon tracking form. And so we asked for whether it was a base bid or an alternate bid, the amount of concrete, and you know, what the unit costs for those different materials were, as well the global warming potential is listed. And in this way, we can compare cost and embodied carbon to identify any easy wins. And you'll see here the list of different elements that we are requesting to be tracked. Focusing more on concrete, for the base bid on this one, we actually had the maximum or the base bid be a maximum global warming potential that was listed in the structural drawing. So we came up with this global warming potential table that you'll see on the bottom here. And for example, foundations.
Yeah, I'm good, thank you.
Foundations have 182 kilograms CO2 per cubic meter. And then if the alternate bid then would be lower than those targets. And this is how it turned out for concrete. That was a good story here where we have a lower carbon bid that came in that was only $9,000 more expensive, or 0.1% on the concrete budget. So an example of that is what's shown on the right, where, like I said before, we had 182 was our maximum, and when the bid came in, it was at 130. So we were able to claim additional savings after the building permit by this procurement method. There's a fair bit to get into here on the mass timber approach, and yeah, I'll gloss over this a bit, and we can talk a bit more about it in detail in the questions if there's time. But yeah, one of the key pieces in that initial design stage was setting a project on a rigid grid so that we're minimizing transfer slabs, aligning the columns from space to space, and thereby improving the structural efficiency of the project. So that helped a lot to enable mass timber. The other thing that helped to enable mass timber was the fire code approach, which didn't allow for a building of this size to be constructed with a combustible structure. So the gymnasium portion of this project was actually separated out and assigned different exiting strategies and fire ratings between the gym and the rest of the building. A lesson learned from this mass timber approach that Carolyn touched on is that the suppliers for this product, Kalishnikov in this case, were engaged very early in a design assist method. So if there's a product that you're wanting to identify early on, it makes sense to engage with them really early. And this was done very early on when we thought that biogenic carbon could be counted as a negative number. You can see in the table below, we have this global warming potential biogenic, which has this negative carbon flow at the beginning. So it was thought at the beginning of this project, before the release of the embodied carbon guidelines, that would count negative, and that was our sure shot to meeting the 40% reduction target. And as the methodology has evolved, we've come up with better practices, or conservative practices at least, that are accounting for only that fossil line of biogenic and counting the biogenic carbon separately. Yeah, so as Carolyn mentioned, we were able to reduce a significant portion of the parkade. And yeah, that accounted for almost half of the embodied carbon emissions that were reduced for this project. Saved the project a lot of money, almost $3.5 million approximately, and really shows the value of build less stuff, cost less, is less emissions. Very simple. So if your projects can minimize below grade parking, that was a key win for us, and a strategy that we're taking into our other projects as well. We looked at rebar, and in the end, it didn't make sense. When we got the lower carbon alternative bid, it was 15% cost premium and yeah, a high dollar per ton CO2 reduced. So we didn't go for this one. We've started to receive shop drawings for the rebar and are noticing that it's being sourced internationally, which is interesting when you think about assuming a project industry average in EPD that was for North American rebar. So that's a question we have as we go into the as-built whole building LCA, is what those impacts might be. For the insulation, there were few alternatives for the walls that were found. I noticed you had a question about the possibly using biogenic carbon materials. We did look at that, possibly using Gutex, and in the end, due to resiliency concerns, mineral wool was the product of choice. And so there's the same amount of mineral wool insulation in the proposed and the baseline. For the roof and floor, they required to have XPS insulation due to the high compressive strengths and resiliency requirements. So we sole sourced Suprema XPS insulation because it has much lower global warming potential, especially because of its blowing agents that are used. So that came back from procurement, and no significant cost premiums were identified. So let's take a look at how the embodied carbon results changed throughout the project. At the building permit stage, we actually weren't meeting this 40% target. We'd shown pathways to achieve it by this alternate bid strategy, and which we ultimately did achieve. So you can see that 19% is from the parkade, and then we have 10% from the hybrid mass timber structure, 4% each for the lower carbon concrete and XPS insulation. What we actually procured to date is much lower embodied carbon concrete than what we had assumed at the BP. So that's what gets us to our 40% target and shows that procurement stage again being key. So remember that 250 value that we set at the beginning of the project? Well, we ended up exceeding that. Turns out that community centers are more carbon intensive per square meter than your typical MURB. But we can also see that the baseline here is quite high, at over 600 kilograms CO2e per square meter. So we know that we had achieved significant embodied carbon reductions for this project, both on a % reduction basis and on an absolute basis, just looking at these hard and true ways that we address the design of the project and evolved the design. Looking at the cumulative emissions from the project, it's clear that the upfront carbon emissions are the key factor here. This is primarily because the operation of the building is all electric and passive house. So this is a cumulative emissions, mind you. So over the 60-year lifespan, we have a small amount of emissions from the operation of this building. And it's more so having to do with the construction, transportation, all the way, yeah, and the materials, the way that the materials are made in this A1 to A5. We have some allowance for replacing of materials as well in the B stage. So to summarize, we had a very ambitious target from the client with field innovation for this project. The mass timber structure that we thought was going to be very low carbon wasn't as low carbon as we thought. It did provide some benefit, but not as much as we are thinking in the pre-design. And the key here for us was that sufficiency is a climate change solution and it costs less. So if we can build less, use less materials, that's a win for everybody. Procurement stage here was essential to realize these embodied carbon reductions because that's when it's actually proved. So following up through the procurement process was really important. You can see the stage of the project here in the upper right-hand corner, thanks to Klishnikov and for that picture. And the next steps for us are to continue to track these EPDs and material quantities during the construction stage, and then conduct a whole building LCA at substantial completion to include more information than we had at the building permit. Big shout out to the design team here listed on the screen. Yeah, they were very important, and yeah, Heather Ray as well on this list. So thank you to all involved parties. And at this stage, we can take some questions.
Thank you, Forrest. Thanks, Carolyn. We really appreciate you taking the time to give us this presentation. So as just for anybody who may have joined halfway through or later on, just to remind and introduce myself, I'm the program manager for CLF BC. So let's jump into the Q&A, and I'm going to, maybe Susan, if you want to start us off.
Sure, yeah, and thank you. I see some of the folks have been answering questions in the chat as they go, so we tried to keep a record of what ones are already answered. But I think this one was for Forrest. How did you come up with the global warming potential numbers in the structural concrete specifications?
Great question. So looking at the concrete specs, we worked with Fast and Ep and Heather Bray to look at what had been submitted historically for their other projects and what was available on the market. Looking at EC3 is another great way that yeah, you can see what is available currently in the market. EC3 from Building Transparency, it's a website, and you can search by location and view what EPDs are available for your specific area. So in that manner, we set a target that was achievable and we knew was available in the local markets. We also focused more significant reductions on the components that could have longer cure times, like the foundations, where there was not much impact on the construction schedule.
Thanks for that, Forrest. Stephanie, do you have a question that you found from the chat there?
Yeah, I hopefully I'm not skipping any, but I wanted to and I know that there's a hand up, so we'll go to that next. But a question I see here is from Jason Wen about the space planning, and it was about in terms of ceiling heights and mezzanines, you know, were those weighted against heating demand, TEDI targets, embodied carbon targets, or were those defined by the OPR?
Those are set in the functional program as well as by licensing requirements for Vancouver Coastal Health in the case of the childcare. So determined by the client is the short answer.
Awesome, thanks. Maybe before I go to you, Susan, for the next one, we can welcome Craig to feel free to turn on your camera and you know, open the mic and ask your question, and also introduce yourself before.
Speaking of the client, I think Craig is from the City of Vancouver, so he's been answering some of the questions.
Oh, thanks.
Yeah, he is.
Yeah.
Okay, never mind, Craig. I don't even know if you're there and heard this. So maybe Susan, if you want to take it to the next question.
Sure. There was just one. Oh, sorry. Zoom just skipped ahead on me there. So someone asked about, it seems that both baseline and proposed designs have triple glazing as their emissions are the same. I think the triple glazing was a comment that you'd mentioned in there, Carolyn. Were you showing savings on that, Forrest, in your savings chart? Okay.
Yeah, the thermal envelope is the same between the baseline and the proposed for this project, with the exception for the one insulation product, Sopra Suprema XPS insulation, which was swapped out for, yeah, because it's lower carbon.
Oh, interesting. Okay, so you kept that part of it the same. I have to say, personally, I really loved your message of just like simplicity and like how much can be saved and achieved with just kind of keeping things straightforward and simple approach.
Thanks. And I
Stephanie.
will say too that this project, something I would like to mention as well, is that the envelope of this project wasn't the key driver in embodied carbon emissions. So when we focus on the structure more so, that really reduced and what enabled us to hit this 40%. Yeah, with that envelope not being as much of a contributing element as we might have thought.
That's good to hear too, from like a passive host perspective, right? That you can still design with a really robust envelope. Stephanie, do you have another question?
Yeah, there's a good question in here that I do want to get to, but just because we are on the topic of glazing, and you know, you talked about the various options that were considered, was double glazing looked and compared to the triple glazing in terms of the whole, you know, story of embodied and operational carbon? Just because I know in some Part 9 buildings in the past, the differences when you balance out the embodied carbon and the performance, sometimes in the big picture, it would make sense to stay with or to just use double glazing. Did that occur, or was that just like it just didn't work out in that way?
Yeah, I can take that question. Speaking for this project specifically, triple pane windows were required to meet the passive house criteria. So double pane windows were not looked at. And we did not do an analysis for this project on double pane versus triple pane windows. I can say that is a question we're seeing a lot on our project, and it's a very complex answer that we would need another hour, I think, to dig into, looking at operational carbon emissions rates and questioning the UPDs that we're using. It's a complex question for sure.
Thanks. And so just to go to the question in the chat, Olfata, I hope I'm pronouncing your name properly. You asked about the reduced number of parkings for the community center and if it was counterproductive in terms of, you know, making it accessible for people to get there for the various activities. And you know, you said centered in you go to a rec in your neighborhood. And you know, that parking is often at capacity. So maybe just in the full picture, when we think about ways to reduce emissions, were there workarounds because of the location in terms of transit oriented and accessible that way that helped combat this? Or do you have were there some juggling of trade-offs that you had to make some tough decisions there?
Yeah, and this is where our work with Bunton Associates, our transportation consultant, was really key. And when we did implement transportation demand management strategies, it was always a conversation with our client representatives to make sure that these strategies worked for that community center. So it's one thing to provide EV charging, but if it's not being used, is that really an effective strategy? So making sure when we picked strategies that would impact our parking count, that they were realistic and effective. In terms of, the community center is located in at Oak Park. It's an area that is predominantly single-family housing, very low density, and there is parking available around the entire perimeter of the park. Although that's not included in our parking count and in our parking calculations, there is that crush zone for parking. And again, it was always working with our client representatives to make sure that this made sense for them, and working with the operator at the existing community center. So yes, something we were very mindful of.
Thanks, Carolyn. Yeah, I see there's another question in here about the chat. This one's directed at Forrest. where you talked about how the mass timber offered maybe fewer carbon savings than expected. Now, was this because the biogenic carbon wasn't included in the embodied calculations, or did the mass timber itself have higher embodied carbon than you'd expected?
It was the former. We at the beginning of the project, we had thought that we could count the biogenic carbon as a credit, and the biogenic carbon stored in the wood could be counted as a negative number that's included in the project total. And then at the end of life, that there would be some benefit for that wood biogenic carbon being stored either in a landfill or possibly having some additional benefit from incineration and energy use at the end. But as the standards progressed, because we started this project before the embodied carbon guidelines were released. So when they were released and it became more clear that there's some uncertainty about forestry management practices and whether biogenic carbon should or shouldn't be accounted for, that it would be more conservative to exclude biogenic carbon from the totals, sow it separately and not count that towards the project embodied carbon reductions.
That makes sense. And it sounds like the work you were doing here must have helped inform some of those guidelines then.
Yeah, we were really honored to be asked to do that, working with Patrick, Sarah, and Anthony Pack as well on the development of those guidelines. So it's really proud of that and how that shaped these requirements that have now been adopted on a national level into the whole building LCA practitioner's guide from the NRC.
I just wanted to jump in. So Craig actually shared his link with me, which is why we're both under his name. But I'm Emily Lombard, project manager from the City of Vancouver. So we're both here when you called on us earlier. I think that's where the confusion happened. But I want to say both to Forrest and Carolyn, I think your work on this project has been amazing in moving policy forward, and we're really appreciative of it. But that was my question about the carbon savings for the mass timber, and something we've come back to a few times. And I was curious, have we been looking at the EPDs of the mass timber itself, even if it's not calculated, or did we receive those?
Yes, I showed the Kalashnikov EPD snip on the screen during the presentation. So those will be posted and you can take a look at that. There's also an industry-wide EPD for mass timber that is very close to the Kalashnikov values. So they're similar, and we did include that in the analysis.
Awesome. Thank you very much.
Thanks for that. I don't see any other questions right now, unless I'm missing. I do want to say thanks to Alistair, as you're talking about the FSC. It's good conversation there. So if people are missing it, take a look. But if anybody else wants to jump in, if you want to raise your hand first or just go. I see the poll was shared, the closing poll, so please do respond to that. But if I don't see any other question, maybe I could ask one if the time permits. It's again related to some of those challenges with supply chain, and especially how in the years of the pandemic, how much mass timber in general took this like big hit in terms of cost premiums. One, as I say that, recognizing the various goals and principles there and how they overlapped, and the biophilia influencing the prioritizing of mass timber, was some effort done even in exploring and comparing life cycle costs of various low carbon materials in relation to also the mass timber, and like balancing premiums there.
I'm not sure I understand the question.
Sorry, as I concluded, I was like, I think I made it confusing at the end. It was more about, let's say you were thinking about low carbon insulation or low carbon concrete. If that was more affordable in the whole, this ambitious but achievable, I know we use that word, like targets that you're trying to go for, although 40 to some people might just seem too ambitious. But if cost premiums for low carbon concrete would have, shown substantial differences than going with mass timber, would that have influenced the use of mass timber? Or was mass timber something protected because of the biophilia goal?
I think it was always a balance, and I know we call it a mass timber structure, but it is a hybrid structure. There's not only mass timber, there's concrete and there's steel. And I think that discussion of the beams really illustrates that, where we wanted as much timber in the building as possible because it is a beautiful local material and we really wanted to celebrate that industry. But when we did tender that timber package, we just weren't able to get those long span curved beams that were such a central part of the design. So it was that big decision-making process. And luckily we were able to work with Kalashnikov, and they really did help guide us to have these tailored some of the redesign so that we kept the essence of the building and we kept as much of the timber, and we're able to stay true to these goals as much as possible, but still able to balance that with all of our cost requirements. And the question, I guess, did come up again when we were looking at the elevator core. Our elevator core is CLT, and that was a whole engineering exercise in itself. And we did explore whether we should use concrete in that when we started to kind of analyze the issue, but really wanted to stay true to those to that mass timber structure and to those embodied carbon goals.
Thank you. Thanks. And I did miss a question from Charlene just about the carbon emitted in the times vehicles are spending. Did you want to unmute and ask? I know that we only have a couple more minutes for some final thoughts, but if you wanted to ask that out loud.
Oh, yeah, thanks. No, it actually wasn't a freestanding question. It relates to the previous one by Ulfat Omar, which was a good question. I was just saying, yeah, that is a real question. I mean, somebody's got to calculate this. I suspect it might fall to the parking consultants to do this kind of in-depth stuff, but I'd be curious to know the answer. Ulfat posed it. Presumably, there's a bunch of complexity that a non-expert like me doesn't appreciate, but I do wonder what the answer to those questions might be.
Mm-hmm. Well, yeah, it's great questions. And, maybe just, maybe before we get to it, if you want to stick around, depending on Forrest and Carolyn's availability, but I like this topic, and part of my, segue into closing and wrapping this up is to just share also that we have the CLF 5-year anniversary next week, which I'll share the link to. And, this is an example of great questions and to discuss with each other when we're there. I, particularly am interested in it because when we find the balance between these reducing emissions and decarbonizing transportation as well as buildings and energy, renewable energy systems, what are we considering within the boundaries of, like, by integrating and removing parking, how does that impact the carbon of the individuals occupying that space, because you're reducing their carbon footprint by incentivizing and moving them in more sustainable ways through like public and active transportation. So hopefully we can chat more about that. But yeah, so we welcome you to join us next week. I'll send the link again. I'm pulling that up. And just a reminder to visit our website because there's just like so many resources for you to access there, including the low carbon material sourcing guide that I just wanted to highlight, especially because Reload Sustainable Design and in particular Forrest was, doing the work on this and is now helping to manage maintaining it. So please do visit that. Thanks, Kim. I see you're dropping the chat, and even just on the previous slide, it showed the Near Zero 2 program, which we are just holding some space for some large Part 9 projects to be entered for the program. So please do either reach out to myself or Kim about that if you're interested in it, or just feel free to just start applying to it directly. Final thing is there's also an event in Victoria on Tuesday, October 22nd. It's a free event, social, kind of casual social get together from 5 to 8. So if you're on the island and are sad about not making it to the 5-year anniversary, hopefully you can at least join us for the social in Victoria. And aside from that, I think we'll just say one more final thanks to our presenters, our co-host, Susan, Natalie, as always, for doing such an amazing job with facilitating these Decarb lunches, and all of you for making the time to be here today.